periodic table looks like, you'll see that it usually has something called atomic notation. Now, when we refer to atomic notation, we're talking about how we represent the elements in our periodic table. Now, you will notice that some periodic tables are a little different in the order in which they put the notation, but really the numbers mean the same thing. So if you have a chance to look at a periodic table and look for the element chlorine. So this is the element chlorine. If you look at the symbol in your periodic table, you'll see that it will have a number at the top and a number at the bottom. So what do these numbers mean? Well, first of all, the symbol for chlorine is Cl. So this is referring to the symbol of the element. And then we have these two numbers. The number at the top in this example is referring to the mass number, and the number at the bottom is referring to the atomic number. So what are these numbers really referring to? The atomic number, which you see here at the bottom, this number is actually telling you how many protons are in the atom. So the atomic number is really giving you information about your element that you're looking at. So it's telling you the number of protons in the nucleus, because remember that's where they're located, of an element atom. So by looking at this and seeing that chlorine has an atomic number of 17, that is telling me that I have 17 protons inside the nucleus of a chlorine atom. So that is what it is telling me. So what is the mass number or the atomic mass? Right? You can use those terms interchangeably. So the atomic mass is telling me the sum of the protons and neutrons in the nucleus of an atom. So here, the atomic mass, of chlorine being 35 is telling me that combined, I have 35 protons and neutrons in the nucleus of the chlorine atom. So an equation that is really going to help you with this is atomic mass is equal to the number of protons plus the number of neutrons. So let's look at it here. Let's see if we can use this equation to calculate the missing number. So our atomic mass for chlorine is 35 equals the number of protons. Well, we know that's the atomic number, so that's 17, plus the number of neutrons. I'm just going to write neutrons here for short. So if I rearrange my equation, it'll be 35 minus 17 is equal to the number of neutrons. I'm just going to continue over here. And if we do that, 35 minus 17, 18 is equal to the number of neutrons in chlorine. So this equation helps us actually calculate how many neutrons are inside the nucleus of the chlorine atom. So this formula right over here is very, very important. I wouldn't say formula, sorry, equation, in helping you find information about an atom given the numbers from the periodic table. So the periodic table is going to give you the mass number and the atomic number. And using this equation, you are then able to find the number of neutrons that is in the nucleus of the atom. So, what else does the periodic table tell me? Well, one rule that you need to know about writing symbols, and I'm going to use chlorine again as our example. When you're writing the symbol for an element, the first letter, if it has two letters, is always capital. The second letter is always lowercase. Other examples, like lead, you'll see that it's an uppercase P, a lowercase b. Copper, uppercase C, lowercase u. So if an element ever has more than one letter in its symbol, you have to remember the first letter is capitalized, the second letter is always in lowercase. That is a rule when you're writing the symbol for any of the elements in the periodic table. Another feature of an atom is that atoms are neutral. And so what do I mean when I say that atoms are neutral? I mean they have no charge. So in total, if I was to look at an atom of an element, the total charge of that atom has to be 0. Now, let's look at which subatomic particles have charges in our atom. We know that our protons, those are the ones with a positive charge. And we have our electrons. Those are the ones that have the negative charge. We don't have to worry about neutrons here when we're talking about charge because neutrons are neutral. They have no charge. So in order for an atom to be neutral, that means that my total charge has to be 0. And that means in order for the total charge to be 0, the number of protons and electrons in my atom have to be equal. So as a conclusion, I can say that the number of protons must equal the number of electrons. And how can I show that to you? Well, let's just look at an example. Let's say there's an element that has 5 protons. Okay, so I'm just picking an element that has 5 protons. Okay, if it has 5 protons and each proton has a positive 1 charge, so each proton has a positive 1 charge, that means my total charge would be plus 5. 5 protons, each one has a positive 1 charge. I have to have a total positive charge of plus 5. Now, let's see if this works. According to the rule, in order for my atom to be neutral, I should also have 5 electrons. Now, each electron has a negative 1 charge. So, each one has a negative 1 charge. Each electron has a negative 1 charge. I have 5 of them. So my total negative charge is negative 5. So what would the total charge be? Let's look at it. What's plus 5 minus 5? Well, that gives me 0. So that shows that for our atoms to be neutral or to not have a charge, it means that the number of electrons and the number of protons in my atom have to be equal. Now I stress this is for atoms because we're going to deal with other particles where there is a possibility of a charge. But in this case, when I'm referring to an atom from the periodic table, the number of protons must equal the number of electrons in order for our atom to be neutral. So let me summarize this for you on a final slide. Here are the main concepts that we have learned with regards to subatomic particles and how we can calculate them. We know that the atomic number is the same as the number of protons. We also know that the atomic mass is equal to the number of protons plus the number of neutrons. And if we rearrange that equation, we can find the number of neutrons if we calculate the atomic mass minus the number of protons. The second and third equation are really the same. It's just presented in two different ways. The third equation is just the second equation rearranged. And in order for atoms to be neutral, the number of protons must equal the number of electrons. So those are the 4 features of atoms that really are essential to remember when trying to look at the different features of the atomic structure.